Talking about solutions, we talked about solids dissolved in water. Now we're going to talk about gases dissolved in water. So we're all familiar with soda. In the Midwest, we called it pop. But a can of soda is an example of a solution where you have a gas dissolved in water, and the gas is carbon dioxide. Most liquids have some dissolved gases in them. If you take, a sample of water that's just been sitting open to the atmosphere, it's going to have air that's dissolved in it. Lake water, seawater, oxygen from the air is dissolved in the water, and that's the air that the fish and the other aquatic life use to live. Our blood also contains gases dissolved in a liquid, water. Those gases would be nitrogen, oxygen, carbon dioxide. So the solubility of gases and liquids also varies with temperature, but it varies in a different way than solids. Most solids are more soluble at high temperatures. Gases are less soluble at high temperatures. You're probably familiar that if you open a can of soda that's really warm, actually you see it more with a 2-liter bottle. You open a 2-liter bottle of warm soda and you see that the fizz is coming out a lot faster, right? And when you pour it, it tends to foam over. Whereas if you pour cold soda, it doesn't do that as much. Once you open the can of soda, you've released the pressure and the carbon dioxide begins to come out of solution. We also observed that cold soda stays fizzy longer than warm soda does. You can try this one at home. Put some water in a pot and heat it on the stove and just stand there and watch it. And what you'll see before it actually begins to boil, you'll see very tiny bubbles begin to rise to the surface. And that's not boiling, that's just dissolved air that's coming out of the water as the temperature goes up. When it actually boils, you'll see larger bubbles and it's very vigorous. So solubility of gases depends on temperature. It also depends on pressure. Henry's law is the relationship that describes the pressure of a gas and the solubility of the gas in the liquid. So here we have illustrations of liquid, and up here we have a smaller number of gas molecules, a low pressure, and here we have a high pressure. And you get a dynamic equilibrium being established here, just like we did with the vapor pressure of a liquid. But here the gas molecules can become trapped in the liquid, and they can also escape. When there are more gas particles above the liquid, then there will be more gas particles dissolved in the liquid, and so the solubility is higher. This is why a can of soda can stay fizzy for a long time, as long as you don't open it. In that can of soda, there's a little bit of gas above. It looks like air. It's carbon dioxide under pressure. And that's why when you open the can, it goes psst, and that's the release of the extra pressure. Once that pressure is gone, then the CO2 begins bubbling out of solution. The CO2 is more soluble under high pressure of CO2. It's less soluble under low pressure of CO2. Any questions?